some places refuse to give up their secrets. They remain hidden for centuries, untouched by civilization, waiting patiently for someone curious enough to ask the right question. This is the story of one of those places, a place where a glacier appears to bleed. Far beyond the last cities, beyond the forests, beyond the oceans, lies the most isolated continent on Earth, Antarctica. A world of ice stretching farther than the eye can see. The coldest place on our planet, the driest, the windiest, a land where temperatures can fall below -60 degrees Celsius. To most people, Antarctica appears silent, frozen, unchanging, a place where time itself seems to have stopped. But beneath this endless expanse of ice, the continent is anything but lifeless. Along the frozen edge of the Ross Sea lies one of Antarctica's most extraordinary places, the McMurdo Dry Valleys. At first glance, they seem impossible. An Antarctic desert, although surrounded by glaciers, these valleys receive almost no snowfall. Fierce katabatic winds descending from the polar plateau strip away fresh snow before it can accumulate. Many scientists consider it the closest natural landscape to the surface of Mars. Life struggles to survive here. Water is almost nowhere to be found. And yet, hidden within this frozen desert, one of nature's greatest mysteries quietly unfolds. At the western end of Taylor Valley lies Taylor Glacier, a vast river of ancient ice, flowing so slowly that its movement is almost invisible to the human eye. Nothing about it suggests that it is extraordinary until you reach its terminus. Without warning, a stream of deep crimson water emerges directly from the face of the glacier. It stains the brilliant white ice below with shades of rust red. The glacier appears to bleed. In 1911, Australian geologist Thomas Griffith Taylor became the first person to document this remarkable phenomenon. How could liquid water exist in one of the coldest places on Earth? Why was it red? Where did it come from? For more than a century, blood falls remained one of Antarctica's greatest unsolved mysteries. But every mystery leaves behind clues. And soon, science would finally look beneath the ice. For more than 100 years, blood falls refused to surrender its secret. Scientists measured its temperature, collected its water, analyzed its chemistry. They returned again and again, hoping each expedition would finally explain the impossible. Instead, every discovery revealed another mystery. The breakthrough came not from what scientists could see, but from what they could not. Using ground-penetrating radar, researchers scanned deep inside Taylor Glacier. For the first time, they could look beneath the ice. What appeared to be a solid block of ice was anything but. Hidden within the glacier lay an intricate network of microscopic fractures and narrow channels, a natural plumbing system, invisible from the surface, slowly carrying liquid water through the glacier itself. But where had this water come from? To answer that question, scientists had to travel back millions of years, long before Antarctica became a frozen continent. The Ross Sea stretched much farther inland. Taylor Valley was once beneath the ocean. As the climate cooled, glaciers advanced across the valley, The seawater became trapped beneath hundreds of meters of ice, cut off from sunlight, cut off from the atmosphere, hidden beneath the glacier for millions of years. Time transformed that ancient seawater. As more ice formed, pure water froze first. The remaining liquid became richer and richer in salt, until it became an extremely concentrated brine, so salty that it could remain liquid at nearly -17 degrees Celsius. Yet remaining liquid was only part of the story. Taylor Glacier is always moving, slowly, almost imperceptibly. Its enormous weight creates immense pressure, and that pressure forces the ancient brine through tiny fractures within the glacier. The journey is unimaginably slow. A single drop of water may spend centuries, perhaps even thousands of years, traveling through darkness before reaching the edge of the glacier. Along the way, the ancient brine slowly dissolved iron from the rocks beneath the glacier. For centuries, it carried that invisible iron through the frozen darkness. When the brine first emerges, it is almost clear, but the moment it meets oxygen, everything changes. The dissolved iron begins to oxidize. Within seconds, the water turns deep crimson. The glacier is not bleeding. It is rusting before our eyes. More than a century after its discovery, the mystery had finally been solved. Blood Falls was the visible expression of an ancient ocean, hidden beneath a glacier. But as scientists continued studying the brine, they made a discovery far more astonishing. The water was not empty. It contained life. The discovery stunned the scientific community. For more than a century, Blood Falls had been studied as a geological mystery. Now, it had become something far greater. Hidden within the ancient brine, scientists found life, not fish, not plants, not even algae, only microscopic organisms, living where life should have been impossible. For nearly all life on Earth, the sun is the source of energy. Plants capture its light. Animals depend on those plants. Entire ecosystems are built upon sunlight. But beneath Taylor Glacier, the sun has never reached these waters. There is no daylight, no sunrise, no sunset, only endless darkness. Yet life survives. These microorganisms have evolved a completely different strategy. Instead of drawing energy from sunlight, they rely on chemistry, using iron and sulfur compounds dissolved in the ancient brine. They produce just enough energy to survive. It is one of the most extraordinary adaptations ever discovered. Life powered by rock, water, and time. Scientists believe this hidden ecosystem has remained isolated for well over 1 million years, perhaps much longer, while civilizations rose and fell, while continents continued to change, while history unfolded above the ice. This microscopic world remained almost untouched, patiently surviving generation after generation, in complete silence. The implications reached far beyond Antarctica. Blood Falls was no longer just a geological wonder. It had become a natural laboratory, a place where scientists could study how life survives under conditions once believed impossible. Every sample collected, every experiment performed, brought humanity one step closer to understanding the true limits of life itself. The discovery also changed the way scientists search for life beyond Earth, far from our planet. Jupiter's moon Europa hides a vast ocean beneath its frozen surface. Saturn's moon Enceladus conceals another beneath its shell of ice, dark, cold, hidden, much like the ancient reservoir beneath Taylor Glacier. If life can survive here, could it survive there? Blood falls does not prove that life exists elsewhere in the universe. But it changes the question. Instead of asking, can life survive without sunlight? Scientists now ask, where else might life be hiding? Sometimes, the smallest discoveries lead to the biggest question. Even today, scientists continue to return to blood falls, not because every mystery has been solved, but because so many remain. The glacier still guards its secrets, and somewhere beneath the Antarctic ice, its hidden world continues to exist, waiting. Blood falls began as a mystery. It became a scientific discovery, but perhaps its greatest lesson is still waiting to be understood. For more than a century, blood falls has challenged everything we thought we knew about glaciers. What first appeared to be a strange red stain upon the ice became one of Antarctica's greatest scientific discoveries, not because of its color, but because it revealed an invisible world hidden beneath our feet. Today we know that Taylor Glacier is far more than a frozen river of ice. Deep beneath its surface, ancient seawater continues its slow journey. A hidden network of channels quietly carries iron-rich brine toward the light. A journey that began millions of years ago and continues even now. Every crimson drop tells a story older than humanity itself. Blood falls reminds us that nature rarely reveals its secrets all at once. For decades, scientists searched for simple answers. Instead, they uncovered an ancient ocean, a hidden hydrologic system, and an ecosystem unlike any other. Every discovery opened the door to another mystery. Perhaps that is the true beauty of science, not the certainty of knowing, but the courage to keep asking. Every generation builds upon the discoveries of those who came before. What was once impossible to explain becomes the starting point for new questions, and somewhere beneath the Antarctic ice, many of those answers are still waiting. Antarctica remains one of the least explored places on Earth. Beneath its immense ice sheet may lie other hidden lakes, other ancient ecosystems, other stories that have remained untouched for millions of years. Blood falls reminds us that even on a planet we believe we know, there are still places capable of surprising us. The crimson water flowing from Taylor Glacier began its journey long before the first humans walked the Earth, long before cities, long before history, long before the first story was ever told. Patiently, drop by drop, it traveled through darkness, until finally reaching the surface, a silent messenger from Earth's distant past. Perhaps the greatest lesson of blood falls is not about glaciers, or chemistry, or even life beneath the ice. It is a reminder that curiosity has always been humanity's greatest strength. Every great discovery begins with a simple question: why? And sometimes, the answer changes the way we understand our world. In the endless silence of Antarctica, blood falls continues to flow. It asks for nothing. It demands nothing. It simply reminds us that our planet is still alive with mysteries, some hidden beneath forests, some beneath oceans, and some beneath nearly half a kilometer of Antarctic ice. Perhaps the greatest mysteries are not the ones we have yet to find, but the ones quietly waiting for someone curious enough to look.